Hello all, this is Shyam Kumar. Welcome to our YouTube channel Hobby Engineer Tech. Yeah, so this is our second video in this YouTube channel, wherein we are going to discuss about Pega Google PubSub dataset. Yeah, basically in our last video, we have discussed about how to integrate Pega with the Google BigQuery, and we have also done a use case. Yeah, that is a very long video. And yeah, considering that, to make it short, so I have made a series on this Pega Google PubSub dataset. Basically, this series contains a couple of videos, some 3 to 4 videos, which actually divided into uh, explaining about Pega Google PubSub service. Okay, basically Google PubSub service, and also what is the use case we are going to do, configurations at Google PubSub and configurations at Pega side. So how we are going to use the Google PubSub dataset as a publisher, how to use it as a subscriber. Yeah, so we are going to see that through a series of videos. And if you are feeling yeah, it has a slow, please feel free to increase your speed to 1.2x or 1.25x so that it will be more engaging. All right, let's get started. Perfect. Now let us understand what is Google PubSub. Okay. So like most of you heard about various messaging services, right? For example, Kafka, JMS, and AWS messaging queues. There are many. Okay. So yeah, in the market, Google Cloud PubSub also act in that particular segment. Yeah. Now, if I want to define what is Google Cloud PubSub, yeah, very simple. Google Cloud PubSub is an asynchronous and highly scalable messaging service. Okay, and what it mainly does, it decouples the services which produce messages from the services which process those messages. Okay, basically, if you see the modern architecture wherein it includes the microservices, right? Whatever you take, any large application you take, like either it is Amazon.com or Flipkart.com, or you can take any of the large scale application that basically builds its own applications by using microservice architecture. So, what is microservice architecture? Like, let's take a very simple example. Suppose if you are ordering something in Amazon, right? So, uh, when you order, it will be managed by an order managing service. And once you order, so this order has to be notified. Okay, this order service needs to notify another service called packaging service, which actually packages this particular order. And once the packaging is completed, the transport service or delivery service has to be notified from this particular packaging service that it has to be delivered. So that means everything is a system which is actually built as a microservices. And all these microservices needs to be contacted, right? It needs to be communicated. Suppose in a large organization there will be many microservices, correct? Like hundreds of microservices. And yeah, so one microservice can be communicated with the tens and hundreds of other microservices as well. If we want to connect them, okay, so yeah, there are many approaches. We can simply couple all of them. Okay, we can simply couple all of them, and then we can send messages across, right? So, but there will be many problems in that. That is why this Google Cloud PubSub or messaging services, basically they will be used as decoupling mechanism between these kind of microservices. Okay. And this PubSub allows services to communicate asynchronously with the very low latencies of 100 milliseconds. Yeah. And yeah, in order to understand it better, let us understand a problem statement and see how PubSub solves it. Okay. Yeah. Imagine uh, there is a lifestyle clothing company called MSK, which sells clothes online through mobile and web apps. And they have a very large user base. Okay. And they maintain a user activity service. You can see here, right? they maintain a user activity service which receives the user activity which is happening in their website and mobile app. Okay. And this user activity service will continuously receiving the user activity of its users. Okay, now there are 10 different internal applications present in this MSK lifestyle organization. Now, this user activity service needs to send data to all these 10 different services. Okay, one of them is Pega, right? So let us say this application 10 is Pega, which actually ingests the user activity service to define the next best action decisions. Okay. Okay, now if I provide you this particular problem, right? What is the solution you will be having? If you consider me, the first thing comes to my mind is to send the data to 10 applications by calling their own service. For example, this app one will have a API or service, and the user activity service will call that particular API and will send the data. So similarly, the app two is also have its own method. So that should be called by this user activity service. So similarly, all the 10 apps will have their own implementation that can be called from user activity service. Okay, this can be called as a push mechanism, wherein the user activity, whenever it receives the data from the mobile app or web app, the service will push the data to all the 10 applications by calling their own services. Yeah, the second thing comes to my mind is that 10 applications can call the click service or the user activity service. Yeah, click service, I mean the user activity service. This is a pull mechanism, right? Yeah. So basically, these applications can actually monitor this user activity service by calling them every 10 seconds or every 20 seconds or every 1 minute and can fetch the latest data. Yeah, these two methods are coming in my mind. Now let us go to another slide. Do we have any problem in this particular architecture? And what about the solutions? Yeah, the solutions are great, but are they really promising? Are they really scalable? Doesn't they have any problems? Yeah, of course. The common problem is we must send the same data to 10 different services and must implement changes if new services are also introduced. For example, if another five internal applications also needs the data from user activity service, okay, and this user activity service needs to send the data to all those services, correct? Uh, in the push mechanism. Even if you are writing the pull mechanism, yeah, so all the five new applications has to receive the data from user activity service. Yeah, and also we have to make the track of order as well, and also if the what if the services are down? Yeah, that is a common problem, right? Whenever you are having multiple microservices, it's most likely that one or more services are down at some point of time. We must implement the retry mechanism, which retries until the service is up, or we have to fail that particular service. Basically, we have to fail. We have to stop sending the data to that particular service. Yeah, yeah. So these are only few problems to name, but there will be many problems. Okay, that is why these kind of messaging systems are evolved. Yeah. Now, what is the solution? Yeah, solution is to maintain an intermediate system between, okay, the user activity service which is producing the messages and the 10 different applications which are receiving and processing the messages. We'll have an intermediate system which I can call it as asynchronous messaging service, which will be taking care of this receiving and sending the messages. Okay. Now here we are putting our cloud PubSub. Yeah. User activity data streaming with Cloud PubSub. This is our use case. Perfect. Okay. So now, yeah, let's say we introduce some intermediate service which takes care of receiving and sending messages. And this intermediate service can scale like a pro and handles message delivery with a fail proof. Okay. And one of such kind in the market is Google PubSub, Google Cloud PubSub. I hope you might have heard about famous distributed messaging systems like Kafka, JMS. and all other clouds also has this distributed messaging system. Yeah. Unlike other systems, this Google Cloud PubSub is mainly used to handle or stream the analytical data as well. Okay. Yeah. And so now, upon introducing this particular cloud PubSub service as an intermediate system between the user activity service and all the 10 applications or all the 10 microservices, this user activity service will now send the user activity data whenever it receives to a topic in the cloud PubSub. Okay. And all the 10 applications subscribe to a particular topic. Okay. So similar to a YouTube channel. For example, if you subscribe to a YouTube channel and if the owner of that particular YouTube channel has published some video, if you subscribe to that particular um, video, right, you will definitely get a notification or you will get that particular video in your feed. Correct? So similar to that. So you have a publisher, our user activity services, which continuously sends messages to a topic in Cloud PubSub. Okay. And all these 10 different applications will subscribe to that particular topic through subscriptions and will receive the data. There are two mechanisms, namely pull mechanism and push mechanism. Okay. So in the pull mechanism, the subscriber has to pull the messages from that particular subscription. Okay. Every topic will have multiple subscriptions. So suppose if app one subscribes to this particular topic, it has to create a subscription in this particular topic. Similarly, app 2 will have one subscription. App 3 will have one subscription. App 4 will have one subscription, and similarly, app 10 will have another subscription. But all these subscriptions will point to a single topic. Okay. So in the pull mechanism, this receivers or consumers will have to get the data from the particular subscription of that particular topic by uh, calling their remote procedure calls. Whereas the push mechanism, whenever that particular topic receives any message, that will be voluntarily pushing the data to that particular subscription. Okay, perfect. Yeah. So let us understand how PubSub works internally. So for that, instead of having the whole content in this particular PPT, I felt let's understand this service from the cloud documentation itself. And I have provided a link over here. So let us actually go to that particular link. Okay. So in this link, we have something called overview of the PubSub service, wherein you can clearly understand how a PubSub works. So in this screen or in this image, you can see that there are two publishers, and this is the Google Cloud PubSub service. Okay, and here we have a topic. So to this particular topic, publisher 1 and publisher 2 send their messages. So publisher 1 is sending message A, publisher 2 is sending message B. Okay. So when this topic receives a message, okay, and it has two subscriptions, okay, and so this messages A and B will be sent to subscription one and also the subscription two. And this subscription one, okay, is having two subscribers, subscriber one and subscriber two, okay, and these subscribers will receive those messages. Okay. And so similarly, if you take subscription 2 has been subscribed by only the subscriber 3. Okay. And it is receiving the messages. Now let us understand the message life cycle. Okay. So suppose, for example, the publisher publishes a message to a particular topic. This topic will have message storage wherein the message will be stored in over here. Okay. And then for this particular topic, we can have multiple subscriptions. Okay. Remember one thing, the subscription and subscriber both are different. Okay. So subscriber is an application. Subscription is an artifact in the Google Cloud PubSub terminology. So in order to receive the messages, you have to create a subscription for a particular topic. Okay. Yeah. So if I go down here, So let us say publisher publishes a message, okay, that is going to the topic, and this topic will have a message storage that will store the data, okay, and then here we have a subscription, okay. That means whenever a message is received by the topic will send the data to all the subscriptions which were created for that particular topic. So let us say here we have only one subscription, and this subscription is connected to a particular subscriber, and this subscriber will receive this message via pull or push mechanism. And once subscriber process this particular message, he will send an acknowledgement to this particular subscription, okay, stating that I have processed this particular message. Once the acknowledgement received by this particular subscription, then the message will be deleted. Okay, that means next time, whenever the subscriber is asking for messages from this subscription, the deleted messages will not be sent to it again. Okay, yeah. So this is the beauty of this particular Google Cloud PubSub. Yeah, perfect. So now let us say the subscriber is unable to acknowledge or unable to process this message. Then at that particular point of time, instead of sending acknowledge message, it will send NACK message. That means no acknowledgement messages. So whenever that no acknowledgement messages has been sent to the subscription, that means it will mark it as not acknowledged. Then the message will not be deleted from the subscription. Yeah. So these are the main important concepts we have to understand. Now let us understand the subscription overview. Yeah. Okay. So in the subscription, we have to learn about types of subscriptions. Let us discuss two main things: pull subscriptions and push subscriptions. What is a pull subscription? So pull subscriptions uses a subscriber client to request messages from the PubSub server. That means the subscriber will have to request the messages from the PubSub server, whereas the push subscriptions, they use the PubSub server. I mean, PubSub server itself initiate the request to your subscriber application to deliver the messages. So this is the difference between pull and push. So Pega, whenever you create a PubSub dataset, right? So Pega itself will create a pull subscription. Okay, Pega is not going to use a push subscription, whereas the Pega uses pull subscription to receive the messages. All right. So yeah, this is the overview of how PubSub actually works. So now let us understand what is the use case and why we are integrating, why we have to integrate uh, with Pega. Okay, let us understand a small use case and how we are going to integrate it. So let us say in our previous slide, we have seen that there are 10 different applications, right? Out of which, let us say one is Pega. Okay. So let's say Pega is one of the application which needs the user activity data. So what does Pega needs to do? So Pega needs to subscribe to the user activity topic to receive the data. So there is a topic created already in the Cloud PubSub. We will create a topic called user activity, and to that particular user activity, we need to create a subscription, and we have to connect our subscriber. Who is our subscriber? Pega, to that particular subscription. Basically, we need to subscribe to that particular topic via a subscription. So here Pega is a subscriber. But how do we actually subscribe? Yeah, for that we will have to create a PubSub dataset. Okay. The beauty of PubSub dataset is it can be used as a publisher and a subscriber. In our case, we are going to use this particular PubSub dataset as a subscriber. Okay. So Pega PubSub dataset can seamlessly subscribe to the topic, uses the full delivery type. This is the main point you have to remember. This anyways, I will show you in the details tab whenever the subscription is created in our further videos. And Pega PubSub dataset can also seamlessly act as a publisher and can send messages to the topic as well. Okay, that means it can act as both publisher and subscriber. Okay, now let us say we create a PubSub dataset and we will subscribe to a particular topic. Okay, but we have to ingest the data into our Pega database table, right? So for that, what we have to do, we have to use a real-time data flow. Okay, so that the data can be ingested to appropriate data set inside Pega. So yeah, I don't know more if you have heard about real-time data flow. So the real-time data flow will be used to ingest the real-time data. So the source can be Google PubSub dataset, Kafka dataset, Stream dataset, Kinesis dataset. So whenever the data comes into that particular dataset, immediately the records will be processed. In Pega CDH as well, there are many use cases where real-time data flow will be used. Mainly this is used for asynchronous processing. The difference between both batch and real time is very simple. In the batch, you will have a certain records of data. For example, 1 terabytes of data that is fixedly defined, and that 1 terabytes of data is present in a database table. Let us say we have to migrate from there to another system or another database table. Whereas the real time, the data will be sent the data will be received in real time and processed in real time. Yeah. So one example of maybe real time data is user activity data. So whenever user is actually browsing through a particular website, the data can be uh, sent to various systems real time. All right. So perfect. Yeah, so let's close this for this video. In the next video, we will walk through the Google PubSub. We will create a particular topic, and also we will uh, create a service account. Okay, and then we will do our Pega configurations. Basically, we are going to see two use cases. One is subscription use case, and another one is um, publisher use case. Sorry, yeah. So we are going to cover two use cases. Yeah, so see you in the next video. Until then, keep learning. Bye. Thank you.